Let's explain the MCQ questions from module 2. Give an example of a solid solution in which the solute is a gas. So this question talking about solid solution where the solute is a gas. Options are camphor in nitrogen, sodium chloride in H2O, bronze, hydrogen in palladium. For a solid solution, what is the condition? What is the condition? The solvent must be solid. The solvent component must be solid. So for taking the option, what we do is checking in each option in which solvent component is solid. Solvent component is solid. Camphor in nitrogen. Nitrogen is the solvent which is a gas. So wrong option. It is a gaseous solution. Sodium chloride in H2O. H2O is the solvent component which exists in liquid state. Solvent component is liquid, so it is liquid solution. Wrong. Then bronze, all of you know it is an alloy of copper and zinc. Both are solids. So solvent and solute both are solids. Solid solution. Even though it is solid solution, the solute is uh, solid. So wrong in the question. Solid solution in which solute is a gas. Solute is a gas. Here the solute is also solid. So we cannot take this option. Then hydrogen in palladium. Hydrogen in palladium means palladium. Palladium is the solvent component which is a solid. So it is a solid solution. Here the solute is hydrogen gas. So this will be the correct option. It is a solid solution in which solute is a gas. Next question. Choose the correct statements. Molarity is moles per liter of solution, but molality is moles per kilogram of solvent. This statement is correct because uh, this statement is the definition of molarity and molality. Everybody knows. Then molarity depends on temperature. Molality is temperature independent. It is also correct. We have studied uh, the concentration term which does not which contains volume term depends on temperature, but concentration time which does not have volume time is temperature independent. Molarity, its expression contains volume time, so depends on temperature. Molality, its expression does not have volume time, so it is temperature independent. Then molarity is equivalence per liter, not it is wrong. Mole fraction is moles per liter, wrong. Then ppm is equal to percentage concentration into 10 raised to 4. This also we have studied. It is correct statement. So out of 4 statements, the correct statements are 1, 2, 4. So which option is correct? Third option. Then coming to question number 3, from the following select the temperature independent concentration. Temperature independent concentration means uh, the of expression should not contain volume time. Expression should not contain volume time. Molarity wrong because its expression contains volume time. Depends on temperature. Normality wrong. Its expression contains volume time. Molality is correct. Its expression does not contain any volume time, so it is independent of temperature. Mass by volume wrong because its expression contain volume time. So the correct option is third one. Next one, a certain sample of well water contains 0.1% calcium ion. The concentration of calcium ion in the water expressed as ppm. So in this case we have to find out or we have to convert percentage concentration into ppm. We have studied the relation between ppm and percentage concentration. ppm is equal to percentage concentration into 10 raised to 4. Percentage concentration given in the problem 0.1 into 10 raised to 4. Result is 1000. So the answer must be fourth option. Coming to next question, question 5. Calculate the mole fraction of ethylene glycol. Ethylene glycol means E2H6O2 with the molar mass 62 in a solution containing 20% of ethylene glycol by mass. So the components in the solution are ethylene glycol and water H2O. Ethylene glycol, its percentage is 20%. 20% means 100 gram solution contains 20 gram ethylene glycol and the remaining 80 gram water. We have to calculate mole fraction of ethylene glycol. Mole fraction of ethylene glycol. Ethylene glycol is solute. So we have to find out chi2 value. Chi2 is equal to N2 divided by N1 plus N2. N2 is mole fraction of solute. That is ethylene glycol. N2, its value is obtained by dividing mass of ethylene glycol with its molar mass 62 given in the question. Result is 0.32. Similarly, you can calculate number of moles of water N1 by dividing the mass of water with its molar mass. Result is 4.44. Substituting N2 and N1 in Chi2 equation, 0.32 divided by 4.44 plus 0.32. Result will be 0.067. So the correct option is first option. Now moving on to question 6. Density of 1.40 molar solution of acetic acid with the molar mass 60 is 1.084 gram per ml. The molarity of the solution will be, all of you know the molarity equation. Capital M is equal to mass of solute W2 divided by molar mass of solute M2 into 1000 by V ml of solution. In the question, molality is given. Molality means mole letter M. It is given 1.40. It means we have 1.40 moles of solute. Here acetic acid is the solute. 1.40 moles of acetic acid per 1000 gram of water. So in the molarity equation we have W2 by M2. It represents nothing but number of moles of solute or number of moles of acetic acid. So we got N2 value in the molarity equation. Then next task is finding out volume of solution. For this we have been given density of the solution. Density of the solution is given in the question. Density of solution is 1.084 grams per milliliter. For converting density of the solution into volume of solution, we use the equation volume of solution is equal to mass of solution divided by density of solution. What is mass of solution? Mass of solute. Here it is acetic acid. Mass of acetic acid plus mass of solute plus mass of solvent. Here it is water. Mass of water H2O divided by density. Density of solution given as 1.084. How can we calculate mass of acetic acid? We know the number of moles of acetic acid 1.40. When moles multiplied with the molar mass of acetic acid is 60. It will give you mass of acetic acid. Number of moles of acetic acid 1.40. When it is multiplied with the molar mass 60, it will give you mass of acetic acid plus mass of water. It is here you can see 1000 gram of water divided by 1.084. When you work out numerator side, it comes out to be 1084 divided by 1.084. Result is 1000 ml. So volume of solution is 1000 ml. Substituting N2 value and volume of solution in molarity equation, we get the answer. What is N2 value? 1.4 into 1000 divided by 1000. This will cancel. Result is 1.4. So the correct option is second option 1.40. Then moving on to question 7. Calculate the molarity of a solution containing 5 gram NaOH in 450 ml solution. It's a very simple problem. We can use the molarity equation directly. Molarity equation M is equal to W2 by M2 into 1000 by Pml. Everything is given. W2 given 5 gram of NaOH. W2 is 5. NaOH, the molar mass is 40. Molar mass of NaOH is 40 into 1000 divided by 450. Result is 0.28 molar. So option 4 is correct. Coming to question 8. What will be the volume of 0.01 molar HCl required to completely react with 4 gram NaOH? It is a neutralization reaction. In neutralization reaction, at the point of completion of the reaction, we will be using the relationship. Milli equivalence of acid equal to milli equivalence of base. This is the equation which we use for solving this problem. Then we have two different equations for calculating milli equivalence. If normality is given, milli equivalence is obtained by multiplying normality with the volume. Or mass is given, then we use another equation, mass divided by equivalent mass into 1000. So we have two different equations for calculating milli equivalence. If normality is given, we use the equation normality into volume in ml. If mass is given, milli equivalence equal to mass divided by equivalent mass into 1000. Here, in the case of HCl, molarity is given. Molarity can be converted to normality. Normality is equal to molarity into n factor. We have already studied what is n factor. For an acid, n factor is number of S plus ions. Here milliequivalence of acid for HCl, molarity is given. Molarity is multiplied with the 0.01 multiplied with the n factor, only one S plus. So n factor is 1, then volume. This will give you milliequivalence of acid. When we come to milliequivalence of base, here it is NaOH, base is NaOH, mass is given. Mass is converted to milliequivalence using this equation W by V into 1000. W here it is 4 gram. 4 divided by equivalent mass. Equivalent mass of NaOH is same as molar mass of NaOH, 40. So for NaOH, equivalent mass as well as molar mass are same into 1000. Then becomes 10, becomes 100. On rearranging V equal to 100 divided by 0.01. Result is 10,000 ml. Option 4 is correct. Then coming to question number 9, 5 ml of 1 normal HCl, 20 ml of N by 2 H2SO4 and 30 ml of N by 3 HNO3 are mixed together and the volume made up to 1 liter by adding water. The normality of the resulting solution. Here different acids are mixed. Then normality of mixture is asked to find out. In such cases, we are using mixing equation. Mixing equation means normality of mixture. Normality of mixture is equal to V1 N1 of first solution plus V2 N2 of second solution plus V3 N3 of third solution divided by total volume. Total volume. Here the first solution is 5 ml of 1 normal HCl. So N mixture, normality of mixture is equal to 5 ml of 1 normal. So V1 N1 is equal to 5 into 1 plus second solution is 20 ml of N by 2 H2SO4. So 20 into V2 is 20 V2 N2. N2 means N by 2. 1 by 2. It is 1 by 2. Plus third solution we are using V3 N3. Third solution is 30 ml of N by 3 HNO3. So V3 is 30 into 1 by 3 divided by total volume. Total volume 1 liter. In the numerator side we are using milliliter. So denominator 1 liter. Instead of using 1 liter we are using 1000 ml. 1000 ml. On simplifying, numerator becomes 5 plus 10 plus 10 divided by 1000. Numerator becomes 25 by 1000. On solving, result is 1 by 40. Option 3 is correct. Coming to question 10, concentrated nitric acid used in laboratory work is 68% nitric acid by mass in aqueous solution. What should be the molarity of such a sample of the acid if the density of the solution is 1.504 gram per ml? They are asking to calculate molarity of solution. What is molarity expression? M equal to mass of solute W2 by molar mass of solute M2 into 1000 by V ml of solution. Mass of solute W2 and volume of solution, they are not given directly in the question. Instead, they have given mass percentage. Mass percentage, right? Mass percentage. It is given as 68% nitric acid HNO3. Correct? What is meant by 68% nitric acid? Means we have 68 grams HNO3 per 100 gram solution. 100 gram solution. 68 gram HNO3, it is W2. It is W2. Then HNO3 is the solute here. So mass of solute W2 is equal to 68 gram. Then molar mass of HNO3 M2, it is obtained by adding the atomic masses of atoms present in HNO3. It is nothing but 63 gram. 63 gram. So in the expression W2 M2, they have been obtained. Then next task is finding out volume of solution. To calculate volume of the solution, they have provided density of the solution. Density of solution. What is given? Density of solution 1.504 gram per ml. Then mass of solution is there, 100 gram. It is mass of solution. Then we have the equation, density of solution is equal to mass of solution by volume of solution. On rearranging this, we will get volume of solution. Volume of solution is equal to mass of solution divided by density of solution. Correct? Mass of solution 100, density of solution 1.504. On solving, we get the value 66.5 ml. Then we can substitute all these values in molarity expression. W2 68 grams, M2 63 grams into 1000 by VML. VML we have a 66.5. On solving this, we get the result 16.23 molar. So correct option is option 1. From this slide you can take down the notes. In this slide I have explained various concentration types. First one is percentage concentration. It is expressed in three ways: mass percentage, volume percentage, then mass by volume percentage. The second concentration term is parts per million. Third one, mole fraction. Fourth concentration term, molarity. Fifth concentration term, molality. Sixth one, normality. Then we have some temperature dependent concentration terms. Then temperature independent concentration terms. Then I have given some important relationships. First one, concentration equations used in volumetric titrations. Second one is dilution equations. Then we have mixing equations. Then we have a relationship between normality and molarity. Okay, thank you.